Last week, I showed you a meteorite with impact melt veins, geological scars. Dory thought that was pretty neat, so I've got another sample with even bigger melt veins to show you now. Let's take a closer look. The meteorite you're looking at on screen now is a sample of a classified stone that is known as NWA 10213. About 4 kilograms of this stone were recovered in Morocco. And what you're looking at here is a partial slice. So someone took the larger mass of the meteorite, created a slice of it, and from that slice, they sliced a section out of it. That's why you have that sharp right angle there versus the natural edge that you see on the other side of it. This meteorite is classified as an L6 ordinary chondrite. The L means there is a relatively lower amount of nickel and iron metal in it compared to some other meteorites. If you have seen the video I showed you last week of the meteorite we were looking at there, it was an H chondrite. It had a lot more metal in it. This one's a little bit more scarce. You see the metal flecks throughout it when the light catches it. It's there, but not nearly as present as the other stones that we've looked at. Let's not bury the lead any further, though. The interesting thing about this particular meteorite are those dark veins running throughout it. Those are impact melt veins. So it's what the name says. There was an impact event with this meteorite, and then it fractured. And along those fracture lines throughout it, the contents of the stone melted and created those dark veins. Now, we've seen those in lots of other meteorites I've shown you. They're usually a little bit thinner and wispier. The unique thing about this stone is that the veins are so thick. That's not completely unheard of. We do see it in other stones, but it's much rare to see these big, thick impact scars of this sort within the meteorite. So what do these thicker impact scars tell us about the impact itself? Well, it's hard to tell, but we could maybe think that the impact was pretty darn strong. It made the fractures within the stone deeper or thicker, or it could be that the impact resulted in much higher heats, causing more material to be melted, or the impact was the result of slower cooling. So the things that were melted cooled more slowly, allowing the heat to expand more before the cooling slowed that down. It's hard to say exactly, but we can make some educated guesses. Speaking of educated guesses, if you want to be more educated to make better guesses, like the video, follow along. I've got a lot more meteorites to show you with a lot of unique features.